All right, so for this project, we'll be doing a fluid flow analysis around a cylinder. We will be focusing on performing analysis for viscid flow, laminar flow, and turbulent flow. So as soon as we go ahead and we open up ANSYS, we go on the workbench application. We go to fluid flow fluent, and then once we open that up, we get this tab here, and then we're going to want to right click on geometry. And then once in doing so, we will go ahead and open up the design model application. And once we're in the design model application, it'll load up with this orientation for the plane systems. We'll be wanting to work on the XY plane. And so we're going to go ahead and go over to our sketch. We're going to go down to the draw. We're going to go down to circle to make our cylinder in 2D. As you can see, we have our cylinder here that we've drawn. Then we'll go to dimensions and we'll go to general to make sure we meet our required diameter, which is 1 meter. Upon doing that, then we'll go ahead and make our control volume. And in doing so, we'll have to go ahead and make a rectangle. Once we do a rectangle here, we'll go down to dimensions and we'll set it up to be about 50 meters by 50 meters. Once we're done with this, we can go over then to the modeling tab. We're going to want to go over to concept. I'm going to go to do surface from sketches, and then we'll click on the surface here on our sketch. And then we'll just go ahead and generate it, and it'll make this for us. All right, so once we finish that, we go back to the workbench. We should have a green check mark here. And then we'll go into mesh. And meshing would be more for refining our object and our cylinder and our control volume to give us a more accurate value. Here, you'd have to set up several different parameters as far as what kind of method you want for the geometry. The kind of edge sizing that we want for the element within the cylinder. We'll have to do some inflation. Once we're done with that and apply our parameters, we'll have to be doing we'll have to like label our boundary conditions, with the left edge being our velocity inlet, the right edge being the pressure outlet, the top being the symmetry, and the bottom being this the top and the bottom being the symmetry, labeled as symmetry, and then our circle in the middle being our cylinder wall. For this project, I'm doing an element size of 0.15 meters, which leads me to have these values here for my nodes and elements. Let me just make sure real quick that my screen is actually being shared. All right. So then we're going to want to go then into Fluent. Let's go back to here to the workbench. Once we generate our meshes in the mesh app, we update and make sure everything is up to date. And then we'll want to go ahead and we'll click on setup, which will then open up the Fluent app. And once we get here, we have to set up our test conditions. So we'll be on to go to our viscous flow. We're going to want to be doing turbulent, my bad. Once we have that set up, we want to go to our air. And here we have to set up our parameters for what density and what viscosity we'll be dealing with. Because we're trying to perform an analysis of a Reynolds number of 800,000. We'll go ahead and this viscosity will allow us to move forward with that. So now we'll want to go down and check the surface body. Make sure all the parameters are the same. They are, thankfully, so we can keep moving. Our velocity inlet, we want to make sure that we have a magnitude of 10 meters per second. Our cylinder wall, we are not having any movement, so it should be stationary. We have to go into our reference values to make sure all our values make sense. Our area, our density, our depth, Our velocity magnitude and our viscosity all look right, so we should be okay. Under methods, we have to set up these parameters for calculation. And then we're going to have to go over to initialization. We're going to be doing hybrid. We're going to be doing that for 35 iterations. Upon initializing that, it'll give us some values. And then we'll be ready to run the calculations for 1,000 iterations. As I've already done this, the data that was given for us, as you can see here, it has the 1,000 iterations. You can see the type of pressure coefficient graph that we get from it, the velocity magnitude that we get for this graph as well. And we can go ahead and go to this screen. If I can find it. Go ahead here and let's go to the post analysis here. Here we see our velocity contour. Pretty much relatively close to zero. Nothing really going on in our graph here. Let's go ahead and pull up our pressure contour. Again, nothing really happening in the area here around our cylinder. And then we can go and check out our streamline, and here we can see that our wake represents that of a typical turbulent flow. And that's pretty much it for this project. Just for the sake of making sure the screens are being showed, I want to show the velocity contour one more time. This is our turbulent flow. And I'll show our pressure contour to make sure, just in case. And there we go, we have that. And then of course we'll have to go ahead and get our forces. Here we have our drag coefficient. We have it over here as 0.228. And then if we want to find our lift comes out to be negative 0.147. And that should be all for our project here.